So in this video, I want to talk about cold start and how you can address them with Cloudflare Workers. So I'm going to show you how you can actually solve this problem in the cheapest way possible. Now, if you've been a developer doing any sort of serious programming in the cloud for any bit of time, you would have come across the concept that we know as cold start. And this is a really, really annoying problem. This is something that I've been really, really obsessed about for a really long time. And I've been trying to figure out what's the best way to actually solve this problem, but while still getting the maximum amount of efficiency with cloud and thing. And in order for you to do that, what it means is you're going to have to be able to scale to zero. Okay. So the trick is you need to be able to scale to zero, which always introduce a cold start problem. I'm going to show you some examples of exactly how cold start happens, because I actually have a real world app that I'm working on right now that has this problem, so that you could understand truly why it matters. And then I'll show you some actual code, demo code of how to actually implement it. I'll give you some walkthrough in a diagram, and then I'll show you how the actual code works itself. So this might be a long video, but if you're interested in solving this problem at the cheapest cost possible, stick around until the end. So let's just jump right into it. By the way, if you don't know me, I'm a .NET developer, been a developer for over 20 years now. I'm making a journey over to Cloudflare. I'm just sharing my experience on that way. If you're interested in watching more videos like this, feel free to subscribe and like us. So with that, let's just back up a bit and just talk about cold start and what it is and why it actually is a problem. So if you don't know, or you've never really heard of the term, cold start is essentially the time it takes for a computer to sort of like boot up and serve the first request. So if somebody goes to like google.com or whatever it is, pick your favorite website, there's a kind of a lag or a delay between the first request that comes in and actually the data server spinning up. This is what we know as cold start. And that lag could actually be anywhere from a couple of microseconds to, in some cases, maybe as a minute or two or whatever it is. It just depends on the application, how complex the application is, etc. This problem is especially more prevalent in sort of the serverless world. And I've been transitioning all of my applications to serverless, Lambda if you're from the AWS world, or Google Functions if you're in the Google space. And the reason for that is because Lambda functions and Google Functions and Azure Functions are sort of like the cheapest way in most cases to run lots and lots of small micro bursts of workloads. Now, there's a different conversation if you're doing really, really extreme volume. It might not be the cheapest, but in these sort of burst workloads that you might have, Azure Functions, Google Functions, Lambda Functions, you pick your battle or your cloud, they are extremely efficient in running sort of these bursty type of workloads. Here's the problem though. Because of the fact that these functions, Azure Functions, if in my particular case, it spins down to zero, which means that if there's no request happening, it actually just goes right down to zero. When the first request comes in, whatever that first request is, it has to endure the cold start. And this is what I call the cold start of death, because it just lags and it just takes a while. And every single thing in Azure, from my personal experience, has been slow with cold start. This is a problem that I've been obsessed with solving. And so I've been trying to figure out what is the best way that you can do this at the cheapest way. That's the most important thing, at the most cost-effective way possible. So with that as a background context, let's just talk a little bit about the actual problem. I'm actually going to switch to my screen now. I'll show you the actual app that I'm solving the problem for, and then I'll talk about the architecture. And like I said, we'll talk about code in a bit. Okay, so I have my app on screen, and this is a real world app. This is not a play toy app. This is a real world production app that actually exists in the real world. And I'm going to show you exactly what happens when I press the send verification code. So basically I'm doing a OTP, one-time password verification. I need to put in my phone number. It's going to do a bunch of backend service stuff, and it's going to send the verification code. Now, it doesn't matter what the code is or login. I'm not even trying to show you the app. What I'm trying to show you is to let you experience cold start, because I happen to know that this is running in a test environment, and so there's no servers running at this particular point. So let me just show you what actually happened. 1, 100, 2, 100, 3, 100, 4, 105. So that spinning that you're seeing right there is actually, oh, you know what? I put in the wrong phone number, but that's okay. Doesn't really matter. That spinning that you're seeing there, that time that you saw that sort of request, is the time that it took for the server to actually spin up. That's the annoying thing. Now, that might not seem like a big deal, but if every single time your servers go down because it's trying to keep your costs low, you have this sort of like very kind of laggy experience from the system doing a bunch of stuff, this becomes a problem. Let me show you another example just to kind of drive home the point. So here I'm sitting in another application. This is another application that I have, and what I'm going to do is, by the way, this is all dummy data, so there's no personal information here or any single thing. I have to say this because Google might actually take down my video. This is dummy information. So with that, I'm going to actually make a change. Now, the server has been running, but the update, because it runs on a completely different server, and again, this is a demo account, you'll see what happens. So if you do that, now look at this save in up at the top here. See that? Save in, save in. Sorry, my alarm went off there. So anyway, if you notice, I just made a change and there's a lag of saving for a bit and then it just went away. So now if I make a change, you'll see it happens pretty fast. It'll be save and save, right? So it's just the initial. That's all that it is. That's what the cold start is. This is what the problem is. This is what we're going to solve. And again, this might not seem like a big deal. Most developers sort of ignore it, but over time, what I will argue is that this actually degrades the experience for your customers, for your users, etc. And as a developer that's building a large scale application, this becomes very annoying, especially if you have really bursty type of workloads. Now, that being said, let's talk about the problem for a bit. So let's talk about the ways and how you could actually solve this problem. And then we'll talk about how I'm actually addressing it and how we're addressing it with Cloudflare specifically. In my world, there's only two ways that I know how to solve this problem. Number one is you have a user and they're about to come to your server, whatever backend system that you have. And that backend system is just always on. Okay. If it's always on, then it's always serving traffic. Here's the problem. If you have bursty users, meaning that certain times of the day, there's just lots of traffic on your system, and then other times of the day, let's say like midnight or 3 a.m., there's nobody on your application, then what happens is you end up paying 24 hours and 24/7 for this particular server just to be running. And at the end of the day, what it boils down to is costs. Okay, so you end up paying for a server just to be on, just so that you don't have a cold start. Now, I'm going to make another argument as to why this also matters. If you're doing backend development deployments and you're doing, code changes, etc., because you're making improvements to your application and you're pushing data to the application altogether, every single time you do a push, you're going to incur a cold start. Now, you could argue, well, okay, you know what, we could put a load balancer in front of here and you could swap the load, etc. So as a result, when you swap the load, then the user doesn't get to see the cold start. But you got a problem here, because what it translates to is that for every single time you push data to your application or push new code changes, you have to also ensure that your orchestration or your DevOps tool or your GitHub Actions tool switches the traffic over to the new server or the old server first, warms it up, and then spins back over the traffic, right? So you have to deal with load balancers. You have to deal with a lot of complexity here, which most large enterprise already deals with. This is just a known thing that you just have to deal with. The problem is, it just takes, as your application grows and as more complexity arises, this problem becomes more. Okay, so not only that, it's just costly. And if you're a startup like myself, where you're running on like thin, small margins, you just end up with just way too much cost. So the only other way to address this problem way number two, is you have servers that basically, again, Azure Functions, Lambda, Google Functions, any one of these will address this problem, where they basically just scale to 0. Okay, and then whenever you get the first traffic, then it basically just spins up that server or that function, serverless function, and then starts to request traffic. And it just depends on the service. There's anywhere between a 5-second to 30 seconds, let's say, or a minute of sort of like cold start. And that just becomes really annoying over time, especially if you have just very, very bursty traffic. But more importantly, this is the most important point. Azure Functions and Lambda Functions are extremely good at spinning up and taking extreme requests. So let's just say that your users, you start getting hammered with a whole bunch of users. Those Google Functions or Lambda Functions would automatically scale up to address the workload. And so you kind of end up with this sort of like balancing act of, do I have servers that are always on to address the cold start problem, or do I have servers that kind of shut down to save money and then spin up as the load comes in? Okay, so that's kind of the balancing act. So in today's video, we're going to have our cake and we're going to eat it too. That's basically what we're doing. We're going to do both. That's what Cloudflare Workers will address. So let's just talk about it now that you understand the problem at some level. The application that I showed you has something like this. This is kind of a rough architecture just to give you some context. You got the mobile application that basically calls some sort of function. That function then goes to sort of a verification service. It goes to an identity provider to do some sort of like security validation, etc. And then it sends out a code, SMS code by Twilio. So it's all that stuff is sort of happening in the background. And then again, it returns sort of a confirmation to tell the user to go to the next page. The problem, as I mentioned, and I showed you before, if this server is down or sleeping, the user has to kind of wait for that spinning wheel to sort of get to the next page. And again, it depends on the amount of traffic and what's going on, etc. That could be anywhere from 5 seconds to 30 seconds on average, just to kind of wait for that server to spin up. So Cloudflare fit into this entire model. So with Cloudflare, we have a model where you have the exact same infrastructure, except that you're putting a Cloudflare worker and a queue in front of it. So what you're going to do is you're going to have your mobile app. Mobile app stays the same. What we've done now is with Cloudflare Workers and Queue, we've introduced this layer in front of Azure Functions. And let me just address the elephant in the room here. Cloudflare Workers Queue is a fantastic sort of solution. And normally what people would say is, well, if you're in the Azure world, I can't talk for Google and for Lambda. I know they have equivalents of it. You could put a service bus. Okay. You could put a service bus, or you could put RabbitMQ, or you could put any number of the sort of like, queue service in the front end here. Okay. Here's the problem. Especially in my particular case, I could only talk specifically in this particular use case. Because this is Azure Functions or scaling to 0, okay, they are not running, which means that they don't actually check the service bus for new records coming in. So you end up with a problem where queue data is coming in, sitting on your queue, but your function is just not picking them up. So Azure is obviously aware of this problem. This is not a new problem. So they have something called always on or always ready. And if you check that box, basically you'll have a version of it that's actually running. There's the equivalent of this in Google Functions and there's the equivalent of this in AWS. But the point is that those functions are going to keep running in the background in order to sort of like keep checking or to get that push notification from the service bus or RabbitMQ or whatever system you're using. Queue systems. That's the problem. So it's not that you can't do it, it's that it's still not efficient because at the end of the day, you're still increasing your costs. And that's what I'm trying to address in this particular case. How can you do this at the absolute zero cost without having to incur that sort of always ready cost, paying for AWS or paying for Google Functions or Azure Functions to keep running just so that you could get these sort of bursty traffic. Okay. By the way, if you get any value from this video, please feel to subscribe. It would really help the channel out. I'm trying to grow this channel, boost my ego of some sort. But yeah, anyway, would love for you to subscribe if you haven't already. So with that, let's just talk about the details here now that you kind of got a little bit more in-depth understanding. So the workers, what's going to happen is you're going to hit a worker and that worker will respond back to the user within milliseconds. And then that worker will basically take that information and drop it onto a Cloudflare queue service. And the Cloudflare queue will just kind of sit inside of here. Now, actually, you know what? I just realized there's another piece that's missing here. There's another worker that's going to pick up the data from the queue and it's going to push it over to Azure Functions. Or again, any other function provider that you're looking at here. Okay. Now there's a big difference here. So the first question you might ask is, well, what's the difference? The difference is that again, with the service bus, it will do the same thing as pushing data. So you'll get the same sort of speed, but again, the Azure function has to be on. In this particular case, the Azure function can stay to 0. So the user has already gotten a response. The worker has passed that on to the queue. The queue is now basically pushed it over to a worker. And this is the key. It's a push. It's a true push. So the queue pushes to the worker because it knows all the consumers. So it pushes it actions really, really fast. And then that worker, if for whatever reason the function is asleep or whatever, then it'll actually spin up. So that lag that you just saw will happen on the back end side. By this particular time, the user has already gotten some sort of response that their data is being processed. And then you can at least have it sort of like processing or waiting for your verification code, right? Then obviously that calls the backend service and every single thing else happens the same from there. But again, just to highlight the point, it's not that the cold start does not happen. It's just that the user gets a response immediately. And that's the key, right? That cold start is just hidden from the user. So hopefully you've gotten sort of like the idea or the concept here. And then from there, you could kind of move on with sending that data. Now, there's one other thing that I just want to highlight here so that you could guarantee that this data is processed. Whenever you push the data onto the service bus, let's say let's just pretend, in this case, I don't have to, but let's just pretend that you had to send that data to a database. What you can do is whenever that data comes back to the database, you guarantee that the data was actually successfully entered. And then the queue could monitor to make sure that we actually get a success request. Only when you get a successful request, you could basically take it off the queue. Otherwise, you just re-put it back on the queue so you could go ahead and continue processing. I just want to highlight that point because the workers are extremely good at handling this type of workloads and guarantee that you have consistent latency in your application, regardless of whether your servers are actually running or not in the background. And I think in this particular solution, this is the cheapest way that I know of that I've been able to come up with that truly can address this problem. Okay, so now that you have some understanding of how the infrastructure is set up and what are the benefits of it, let's just look at the actual code and how I've set things up in Cloudflare in order to make this possible and what are the benefits. So right now, if you look into my account here, we have the Cloudflare compute. Okay, so under workers, you have the workers. So under compute and workers, you have Cloudflare workers. And right there, I have a test consumer Hono app. We'll talk about Hono in a sec. And basically this is a worker that's just responsible for ingesting requests. And like I said, it will feed it to the queue, which will then do further background process. The thing that makes this sort of really, really elegant is the fact that the worker is extremely simple. I'll show you the code in a sec, but it's really, really simple. And the thing that I like about Cloudflare and just the implementation of this stuff is that honestly, coming from a .NET background and coming from a sort of like a more traditional sort of client server architecture, every time I come into the Cloudflare system to do stuff, it just feels like a toy. I don't know how else to explain it. It just feels so light and so simple that it's hard for your brain to wrap around the fact that this thing here can scale to literally hundreds of thousands of requests per second, no problem, without even flinching. However, it's just the developer experience is so light and so simple and so unique that it just feels like a toy. And like I said, that's the only way I could explain it. I don't know how else to explain it. So it's taken me a really long time to kind of wrap my head around sort of like just the sheer capabilities that's sort of hidden under this entire application. And once you really, really see like the power, like you can't unsee it. It's like, you can't unsee it. It's like, how did I live without these sort of like very primitive, extremely efficient sort of like use workers or processing before. And just to add some more color, if you don't know what Cloudflare Workers is, it's basically think of it like a Chrome browser tab. This is the best way I could describe it because that's basically what it is. It's actually using V8 engine under the hood. And the way I could describe it is if you clicked on new tab to open a new tab for your browser, the speed of which your tab opens is literally the underlying technology for Cloudflare Workers. Cloudflare is essentially abstracting on a VM, which is basically the V8 Chrome engine at the tab level. That's the simplest explanation that I could give you. So it's literally instant to keep spinning up these microservices. And that's what makes it powerful, because they could just scale up, charge you for your compute, and then just spin down whenever they don't need you. And the minute some other request comes in. So they are technically doing cold start also, but the cold start is so low that it's just negligible. I think that's the word I'm looking for. Anyway, hopefully that gives you some color. So with that, I got a test consumer here. It's going to basically take it right now. I did some test traffic before, and then we have a log here that'll show you in a sec. And I'm going to just put it on live so you can kind of see some live events here. Then I have a test queue that basically has tests records that's going to be coming into it. And the thing about this is that it's very simple. There's nothing really to look at here other than you could click on messages here and you could kind of try this to kind of see if there's any messages in the backlog, and you could purge it, which is a cool little feature right off the top, or you could kind of send a message from here just to the queue directly, right? So you could say like test, and then that'll just send a message to the queue. The thing that I noticed is that the queue, it's not real time. Well, I shouldn't say it's not real time. It just takes a little bit of time, a little bit of delay. For example, I just send that message, it doesn't show up right away. So just kind of keep that in mind. So I have a test producer. The producer is the one that's going to be sending the messages. Okay. So this is basically what it looks like. Here, I could again put it in live mode so you can kind of see the logs. And then what I'm going to do is, just for the sake of just showing you a test, I'm going to do this in Postman first. So here I have a very basic sort of function that's going to just send some tests. And if I just press that, I just sent one test there, and then you see that it just came in. CPU time, 3 milliseconds. Wait wall time, which is the actual real time, 300 milliseconds for the first one. So that was their cold start. Let's do another one. There we go. Okay. So that's working. So see that CPU time, 0 milliseconds, 0 milliseconds, 1 millisecond, wall time, 137 milliseconds to actually send the data. So just to be clear what this is doing, this is taking in a request from here. If you notice, 229 milliseconds, right? So I'm pretty much guaranteed to be getting back a response within about, let's call it under 100, 200 milliseconds. So I'm pretty much guaranteed to do that. It's taken in this request from whatever front end. What it's doing is then repackaging it, dropping it onto the queue. And then the queue, there's another worker, as I mentioned, that will then pick up that request. So then we have another consumer here that's going to pick up the messages. Okay, so see that here. And let's just go into live mode here. So I'm going to go back to Postman. You'll see how fast it comes across in this one here. So if I press send here, there. So this is the second worker that's pulling off of the queue. Actually, I take that back. So this is the one that's doing the processing it at, I think 3 or 4. Let me just see. Let me just confirm. I'm just trying to confirm. Okay, sorry. It's a refresh on the dashboard. Some reason live mode doesn't actually do live. So let me just try that again. So here, send again here. There we go. It might just be that the tab was sleeping, right? So that's basically what's happening. That's why you're not seeing it sort of in real time. So you see it's showing me all the requests now in the last hour. Just want to do 5 minutes. Live, 5 minutes. Yes. Send. Okay. So you got the idea. So this is coming off on the other backend, right? So let's call it where the wall time to process this queue message as a consumer is 200 milliseconds. So, or let's call it 250 or 230 milliseconds. So we're about 400 milliseconds in from front end, 135. Again, I'm going to just round off just to keep the math simple. So let's call it under 200 milliseconds to another 200 milliseconds. So we're 400 milliseconds in on the consumer end. Okay. And then, now I got to make this up. So I got a function, Azure Functions here. There's a test function. I'm going to go to log stream, and then this will show you in real time the messages coming in. So I'm just going to go back over here, send it over, and we should be able to see something here. There we go. Okay. So this is just simulating and saving data to the database just for the sake of this conversation. So send in there, and then, okay. I don't have a way to properly calculate how long it's taken on this end because I'm not doing that thing, but it's pretty much instantaneous. I would say within a second. So just to recap, I gotta, because like I said, there's a service that's missing here. Okay. So it's from here to here. Let's call it 150 milliseconds. Okay. And then on this side here, I'm 230. That's on average. It's a little bit under that, but we're just kind of rounding up right now. 230 milliseconds. So what's that? 380. Okay. And then on this side here, this is now a push. Let's call it another this service is, because it's going to the database and doing a bunch of other stuff, let's call it 1 second, just for the sake of this conversation, okay? So 1 second, or even if your cold start, your cold start would be somewhere around there. It would be a little less than that. Your start would be about 5 seconds. But let's assume that the service is actually up here about 1 second. So from end to end, I'd say you're about 1.2 seconds in. Full processing from end to end. So I think that's actually amazing. And again, I'm not necessarily having a conversation about a cold start this second, just sort of like across the board. That's pretty fast. So from the user standpoint, it's pretty much instantaneous. And I'm being generous. Once that cold start happens, this number will go down. So definitely within a second, but guarantee, even if the server is down, the user still gets back that, let's say 150 ms speed response every time, all the time, all day long. And that's the key. The key is to ensure that the user experience stays consistent regardless of how cheap you are on the back end, okay? And that's the goal. But at the same time, be able to take in 100,000 requests per second instantly with no flinching whatsoever. That's the power of the workers, and that's basically why I'm so bullish about this, because it solves a real problem at such a elegant way that it's not. Okay, so with that, let's just jump into the code a little bit. Okay, so this is what it looks like. Again, I'm going to do another video, a little bit more deep dive on this Hono framework. Hono, just to give you some context, is, think of it like Node or Express in the thing world. It's just the way that the Cloudflare implementation is set up. And this code here that you're looking at is actually not even the code. The code that actually does the sort of the actual work is, So which one am I looking at here? So this is the consumer. We don't want to do the consumer. Let's go look at the producer. Okay, so this is the test producer. Okay, so what I'm doing basically is I'm taking the post from Postman, this random set of information here, taking it as a post request from Postman. That's coming in this app, which is basically just a new Hono object. So I'm just posting to /data. And then all I'm doing is just, this is how elegant it is. I'm taking in the context, I'm getting the request, I'm getting the JSON, and I'm just checking to see if the JSON is actually valid or not. And I'm also checking to see if it's any validation issues. Then I'm checking to see if I have a queue that I could send the data to. The question is, how does it know about this queue? So it knows about the queue because in the Wrangler.json file, which is basically, think of it like a package.json, a config file for Cloudflare, I have a bindings. So I have a producer and I have a queue, and it basically has a queue name, test queue, and then I have a binding. So in other words, this name is how I would refer to it in code. I could name this my queue. If I did that, I would have to copy that name, and in my code, I would have to put this here and here. Okay, so c.env environment variable, my queue, send data. That's it. That's all you need to do to basically pull data in from a HTTP request and then basically forward it onto a queue and log some details, and you got instant, like, no cold start. Absolutely no cold start. That's amazing on so many levels. The level of simplicity of this code and the amount of abstraction that's happening on the back end is unreal. It's unreal. And that's why I think it just fools you into thinking that this is just a toy, right? When it's just so powerful. It's actually the complete opposite. It's just so powerful of an implementation. And the Hono sort of like frameworks is the icing on the cake, because it's really, really pleasant to deal with. If you go look at the Cloudflare worker and their implementation of doing all of this stuff, it's just a little bit more JavaScript boilerplate. Coming from a C# world and working in a .NET world with JavaScript, a little bit of TypeScript, and the Hono framework, it just feels like home. There's just no other way to describe it. It's like I'm in my language, just doesn't have as nice of IntelliSense, right? But it's fine. Like, I can live with it all day long. Like, I'm not a big JavaScript fan. Over the years, I've become to appreciate the language for what it does, because it's so flexible in so many ways. If you're a C# or a Java fan, or even a Go fan or whatever, There's no deserialization, serialization, and convert into a string. Like I'm just forwarding some data, true and true, right? Now, if I really wanted to be strict, I might put some validation and stuff like that, but that's not the point of this conversation. The point is the simplicity of the implementation is just unreal. Okay, so with that, that's my producer. And then my consumer looks a little bit more complicated, but it's not, right? Like, honestly, this entire thing just boils down to this one line, maybe these 3 lines here. The rest is just a bunch of try-catch statements, right? So if I were to literally remove all of the, just for the sake of everything, I'm just going to simplify it here. So we got all this logs. Let's get rid of the console log, right? So I got an acknowledge message, and I have a retry message, and that's it. And even if I just took this try catch out of the way, just for the sake of simplifying, okay? And then let's just get rid of the try catch, just for the sake of this conversation, okay? And I'm going to get rid of even the logs here, just to show you how simple this entire thing is, okay? So what are we doing? I created this concept of a startup just to kind of abstract some of the other stuff, but even that file is not, it's not complex at all. So I got a startup file, and all it does, it imports the Hono, and it basically just creates an app, and it has a global error handling, so app.onError. And if there's any global errors, it's just going to take that error and just dump it onto a queue so it can just move on. This allows it to just go really, really fast, because what it does is say, oh, I got an error. Okay, I'm just going to put it aside and just going to keep moving. And this is just a really elegant way to handle it on a global level. And this here is literally just a basic, just to say, hey, the service is up and running, because I'm just checking for the root level, and I'm just saying, I'm just returning this question mark. So the index file, which is sort of the main workhorse, got to export. It's basically taking a fetch, so it's getting it from a queue, and then this is just the code, just accept it as it is. It's taking a batch, by the way, because I could take in batch of 10 or 20 or 100 of data from the queue at any given time, and then I got my environment variable, access to the environment variable, right? So the question is, how does the env, how does it know which queue to get the data from? Like that, those are kind of the questions that I had in my head. Like, how does this kind of deal? And basically it just boils down to the Wrangler file. So I got a Wrangler file, which is just again, another config file. In the .NET world, it's a local settings.json or a host file or whatever. And I got the same exact thing. I got a queue. The queue in this case has a consumer. The consumer queue is connected to this queue. And right now I'm just taking a batch size of 1. This could be a batch size of 10 or 100. It just depends on the volume of data coming in. I just put it at 1 because I wanted to see in real time each line. If you did was batch of 10, you would see 1 line for every 10 queue message. Hopefully that makes sense. Oh, and then by the way, this is one actually point. In order for you to see the data in the control panel, you have to enable observability equals true. Okay. By the way, I'm going to try to put all these code samples up on GitHub. So I'll put the link below at the bottom so you guys could get access to it, just in case you want to actually sort of browse through it in your own kind of time. Right. I know for me, it just took a little while to wrap my brain around what's going on here. Just the elegance and the simplicity of the code. It's just unbelievable. It's just for the power that you get. And then what I'm doing is just forwarding that message. So the message is coming in here, message.batch, right? Off of the batch thing, getting the message. I'm basically taking the body, which again is a JSON, and I'm passing the environment variable to this forward HTTP endpoint. And that's just a very basic, it's just literally a JavaScript HTTP endpoint. I've even hard coded the keys inside here. Don't steal my keys. I'm going to delete this right after this video. But I got an API endpoint, which is this, and then I have a header for function. Oh, I just realized that it's not even authenticated with any security, because I just realized that our key was there. And I was just doing a post. So pull off the queue, wrap it into an HTTP endpoint, and then just pushing it back out. And that's what this line is doing here, fetch post request, and it's just basically stringifying the JSON object. Every single thing else here is just checking to see if I got an error or not. And again, if it does, it's going to return back to the user. So obviously there's authentication and stuff that has to be added here, but the point is that this is the level of sophistication that's required to add this sort of worker, add the queue, add another worker, and just get insane amounts of power and instant removal of this cold start annoying problem that just been driving me nuts for a really long time. So with that, hopefully you've gotten some value out of this video. Like I said, if you haven't subscribed to the channel, please do. I'm going to be sharing a lot more about my journey on Cloudflare, my experience, and share about real world sort of like challenges and things that I like about Cloudflare altogether. If that's something you're interested in, please feel free to subscribe. And with that, I'll see you in another video. Have yourself a wonderful day.